Hi, everyone. I'm Robbie Stewart, the co-founder and CEO of Boston Atomics and recent MIT PhD alumni. And I'm excited to be here today to talk about my Gen 4 research and development. So I think at this point, we're all aware of the recent construction delays and cost overruns of large light water reactor plants, especially in the US and parts of Europe. And part of the problem, among many problems of these plants, have been that they are very difficult to construct structurally. And we can think about constructability as a function of the building span, so how wide a building is, and the building height, how tall it is. And the higher either one of these are, the more difficult the building is to construct. The British or UK architect engineering firm Bright & Wood plotted a couple of types of structures that have historically been easier to modularize, things like libraries or living rooms, and in some cases, sports arenas or warehouses. But in general, from what they have seen, it is easier to modularize structures that are less than 15 meters in span and less than 50 meters, less than 15 meters in height and less than 50 meters in span. Now, it's to no surprise to anyone if we put large light water reactors on this chart that you get something that's way outside of the easy to modularize zone, 45-meter spans, 60-meter heights. Now, the proposed solution here are small modular reactors, and they do in fact move the needle in the right direction. They lower spans, they lower heights. However, they're still far away, far removed from this easy to modularize section. So what we are focused on at Boston Atomics is design for constructability. How do we get small modular reactors to fit inside of this easy to modularize box? So how do we do that? Well, we start from the state-of-the-art high-temperature gas reactor, which, as I'm sure you all know, has a vertical reactor pressure vessel, a horizontal cross vessel, and then a vertical steam generator. And we take the two vertical vessels, we integrate them into a single flanged vessel, and we rotate that system horizontally. The resulting reactor design is we call MIGHTR, the Modular Integrated Gas-Cooled High-Temperature Reactor by Boston Atomics. Now, the resulting reactor building is 1/5 the height of the traditional. It eliminates wasted space below the pressure vessel above the steam generator. And this shorter building is more site adaptable with lower soil pressures and other attributes that make it easier to scale to more locations. And finally, it fits fully within that easy to modularize box on the left side of the chart. Now, this has not come without significant complications in the operational activities inside the plant. And so there's a few enabling technologies that we're developing now with a number of partners. One is a set of rail sliding supports that allow for accommodating thermal expansions. The second is a robotic refueling machine that allows us to reach into the vessel and grab fuel blocks because we cannot have this simple vertical fishing line strategy of traditional vertical HTGRs. Looking at a printed circuit heat exchanger steam generator, and then using reactivity controlled drums as opposed to rods, or maybe to supplement rods, but as a primary reactivity control system. We have a number of great partners that we're working with to develop this. MIT, the University of Buffalo, University of Michigan, Argonne National Lab, NPR Associates, and some of this work is funded by the U.S. Department of Energy through the Advanced Reactor Demonstration Program's ARC-20 program. Thank you for taking the time to listen to me talk about design for constructability and the MIGHTR reactor. We're excited about this push towards easier to construct reactor designs.